Hi everyone, I'm Barbara Veiga. I'm the Digital Marketing Specialist at Delta Q Technologies, which is part of the ZAPI group of companies. I would like to extend a warm welcome to all of you for joining us in this session. Please keep in mind that this session is being recorded and will be available for on-demand viewing in the future. If you have any questions during the session, feel free to ask by using the Q&A feature located on the right side of your screen. Please note that all questions will be kept private. With that said, I'm excited to introduce our speakers, Murat Shergi from Delta Q Technologies and Andreas Pohl from Inventus Power. They will be sharing insights on off-highway vehicle electrification, best practices in battery and charger integration. Welcome, Murat and Andreas, and please take the stage.
Thank you very much, Laura, for the warm introduction. Also from my side, very warm welcome to this interesting session. Hopefully for you, for us, is always an interesting task, and it's growing all the time in terms of subjects as well, customers and application fields. So Murat and myself, we're here today to talk a little bit about non-road mobile machinery that is basically running off highway, getting electrified from internal combustion towards electric drivetrains. The agenda is roughly looking like we're going through the trends and drivers of that industry. Then towards the machine electrification, we will see the benefits that come alongside with that, and why it makes sense to go actually electric in these areas. We do have then getting more into the technical part of it, so the design considerations, what needs to be taken care of when you look at your equipment and you like to do the transition into electric drivetrains, what is needed from all parts of the components, as well as on partner suppliers that you need to take care of for successful projects. Then later on, we're talking about lessons learned in this area and like pitfalls, what are things that need to be taken care of before you go, and making sure you're not affected by anything in the end that costs you more money than the whole project because you have to start again, missing the most important points. That basically is then closing out with the key takeaways and giving the audience room for questions and answers. And by that, I would start right away with basically looking at the commercial ecosystem. So where does it come from? Where did it start? It's basically an adoption that we see over various industry. So there's a customer acceptance for electric drivetrains for various reasons. Some of that is like stylish, like there's this Tesla hype that started just to put it out there. Some years ago already, being now we see more and more adoption on the roads. Millions of cars being produced and putting into operations, and then basically from here it goes also into all other areas that are non-passenger vehicles, where we see machinery for cleaning, gardening tools, and we all know that the times are already there that batteries and electrification is all around us. All type of equipment. We see then specifically the sector of off-highway and agriculture slowly taking the road into electrification. Also here, starting from different machine sizes. So we have a driver from the market itself. That means it's a regulatory part where machine rental fleets are forced basically to change their equipment into electric, making sure they can still get the projects. Other than that are subjects like maintenance. So electric drivetrains have by far less maintenance, are more reliable in the operation. And that's what we basically see now coming to the non-road mobile machineries. From there, I think we can look at the upcoming trends where we see what's happening at the moment, or what has been happening in the past year. So maybe Murat, you want to move to the next slide? Yeah, so that's we clustered it a little bit into 3 years, because the things happen. It took a long time, but now it seems like the momentum is coming in that sector and things are picking up faster. So a lot of projects are being set up and others have been already closed. So predominantly one can say it started basically with smaller equipment, less than 20-25 horsepower in the sectors already mentioned. So mobile electric equipment that was used to be powered by internal combustion engines in the gardening sector, professional cleaning, larger machines there. Of course, there's a big part in the utility vehicles that have been, from a smaller form factor being transformed. We've also seen commercial vehicles, delivery vehicles being basically in a smaller footprint now. Makes sense to go first electric, because there the range is not the limiting factor for the first place. And so this path continues. We see now, specifically in the off-highway sector, larger machines, then larger battery systems with more requirements on the technology side. Also, the technology is advancing at the same time. So we see the energy densities are growing year by year. The cell technology gets better. Also, everything around that. Speaking for the batteries, similar on the charging side, there's developments. And that means we're seeing from starting this year over the next 3 years, predominantly larger equipment over 30 kilowatts growing into the market. Larger equipment that will be seeing more towards 2030 is then the real big offsite excavator machines that are in the beyond 5 tons, 10 tons size. So that's like the real large machines coming a bit later. But everything in between, we already see like existing projects being finished, others being going into pre-production, mass production soon. And that's basically driven by the whole environmental aspects. The decarbonization is an important thing. And as well as the regulatory, as already mentioned, is driving these markets. So I think now we should look at what are specific advantages that an electric drivetrain has over an internal combustion engine. And at the beginning, the most appealing argument, of course, is the lower operating cost. So if I have an electric drivetrain, then the efficiency overall is much, much better. So when we come from, let's say, at best, maybe a 35-40% efficiency of an ICE drivetrain, then we will see easily, above 90% on electric drivetrains. And that means, of course, energy input output is a big difference there. So on top of that, there is way fewer parts in an electric engine. It means the maintenance itself is less. The equipment is more durable. So overall, that's a big driver, of course. So that's the money basically that makes it happen. So the ROI can be measured just on that figure itself. Then what we see depending really on the area. So here over in Europe, in the EMEA region, there are specific countries that are really driving the electrification. So the Nordic countries are very strong, and there you are forced actually to get green equipment into the fleet, and basically avoid carbon emissions, have an environmentally friendly product to offer. And that's something that shouldn't be underestimated, because if there is a community that decides basically to go electric and the OEM doesn't offer anything, then it can be a quick drop, on the commercial side in terms of revenues, and business model is in jeopardize. So therefore, it has a lot of different angles to look at, and makes in many ways it makes sense to go electric. The part we scratched already with the lower maintenance coming from just fewer parts that don't wear as much as in an internal combustion, where gases are exploding and then through exhaust taken out and oil is sizzling around gears and stuff. So large gearboxes that can be much smaller means there is way less wear out on the components, and therefore the operator sees fewer maintenance cost. Going forward, as already said, some countries come from the regulatory side, but what is clear, if you're standing in front of a internal combustion large machine that is noisy and makes a lot of exhaust that smells and pollutes the air, and you drive in with an electric machine, that's basically day and night, right? So even let's say the non-directly involved operator, means people passing by, passengers or somebody else on the side, will have a positive effect on the engine. Let's say that's the driver that comes for free, more or less, right? One thing that's been found out, and actually Murat, you had a more experience on that, and maybe there's questions, then we can route that throughout the session later, that the operator health comfort is better. So there are specific requirements on how much vibration goes into an equipment coming from the internal combustion engine, and then the operator cannot be exposed to too high vibration over too long time. So there are things that are basically going away if you go electric, so you don't have to even think about these things, and that can be sold again to the customer as a benefit. So it's a more comfortable machine. It's better to operate. It's probably also not so stressful for the operator over time. If you think about a very noisy machine that is vibrating, and you're sitting then in a calm cabin that is efficiently heated with basically no vibration, of course it's a better job to do. And all these things together are very good reasons why people are going towards electrification. And I think at this stage I'm happy to hand over to Murat to tell us a little bit more about the target customers and the users.
Okay, thank you, Andreas, for the introduction and presenting the trends and the benefits of actually going to electrical powertrains. Now, the OEM is making the decision, for example, to switch a machine from a combustion engine to electric for different reasons. It's for many of the OEMs, this is a very new endeavor, and it may be scary. It may be thought like with a lot of risks and anticipation. So we'll go through the rest of the presentation about some details like related to what are some of the challenges or the pitfalls or things that the OEM should consider when they are embarking in the journey to go from a combustion engine to electric. The OEMs are experts in their field where the machine is being used, and they know how it's used, they know its users. But as they embark into electrification, they should consider other aspects they haven't considered before. So they have to identify the target users from different angles. One of them is looking at where the machine will be used and what infrastructure is available there. Infrastructure, especially with regard to power availability, electrical power availability. Where is it from? Where it's coming? Where it's located? And what type of energy is available there? The second one is they have to do another round at looking at the load profile on how the machine is used over time. It's like they understand that when they designed the machine, but now they have to look at it again, because It's not just about converting a combustion engine to electric. There is actually, with electrification, it opens the door to a lot of efficiencies and better performance on the machine that could be rolled in the machine. So a look at the load profiles, a revisit, a study again, and looking at different aspects where the machine can gain a lot of efficiency and performance with this transformation. Another aspect that actually have to be considered really, really early in the decision when moving to an electric powertrain is the relevant regulatory and compliance standards. Many of the vehicles and machinery that are in the marketplace today, they fall under certain categories of regulations, but taking them electric drive this drive new regulatory standards, new constraints, and new challenges. So the OEM have to be aware of of all this context about where the machines used, the geographical requirement, the requirement related to specific geographic areas, to specific markets, and to specific applications. So that's the first part. The second part it has to do actually with defining the vehicle requirements. So here, when looking at look, we're talking about the powertrain. One important aspect that's known is what is like the demand in terms of continuous power. So that's the average power that will be used by the machine as it's doing its job. And that's important in terms of sizing. How big is the battery that need to be on the vehicle? And also it has implications on how often it needs to be charged and rested, etc. So the continuous power is an important consideration, but it's not the only one. We have to look also on the machine at the peak power. It's the maximum, for example, the maximum torque required, or the maximum lifting capability of the machines, etc. This consideration will have an implication on sizing, for example, the cabling of the machine, on sizing the batteries, on sizing the output of the different components of the powertrain. So typically in a combustion engine, these considerations are known. So there is the continuous power and the peak power, and then generally the motor is sized for the peak power. But when you move to electric, it's a little bit different. So to actually try to smooth some corners that maybe the power required may be less. Then the OEM need to look at the duty cycle. So this is how long the machine will be used in the field. So it's not just like how much power, but how long, and the profile of the usage on what it needs to achieve. So that will also have implications actually on the size of the battery, and how fast the charging need to happen, etc. So there is a lot of implications when you look at these aspects with regard to sizing the different components in this machine. A last consideration, and sometimes it gets a little bit overlooked, is looking at the user's scenarios from where the machine will be used. I give an example. So when you have a combustion engine, it generally it output the same power regardless of the temperature, the environmental temperature around the machine. But batteries performance is highly tied to the temperature. So in the colder the temperature is, the less battery energy is available, and that's like just physics. So if a machine needs to be used in a very cold environment, well, the battery need to be upsized actually for these worst case conditions so that it can work properly in those environments. So this is considerations that are typically not thought when considering combustion engine, but for batteries it's very important. It's the environment where the machine will be used, and the different cycles between like summer, spring, winter, etc. So it's different cycles. So that's a consideration actually we're related to defining vehicle requirements. The third stage is now we have defined the machine requirement. Now we look at the components and choosing the right powertrain and choosing the different components. The first question is actually that an OEM should consider is what level of electrification is considered. So electrification has it's not one solution for all. It's actually a spectrum of solutions, going from, for example, taking some functions and converting them to electric, such as actuators or um, 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 or motors, etc., replacing hydraulics with electrical components. So that's one. But it's a very big span. So for example, like the machine could be fully electrified. With the main source of the power is a battery, so that's battery powered equipment. But it could be also different shades of hybrid systems with combustion engine and batteries and electric components, or it could be just electrify some functions. So the level of the electrification is very wide, and that's one of the most important questions actually, looking at now actually at the powertrain. Once that's defined, there is another decision that have to be made that's related to actually the voltages of the traction system as well as the auxiliary functions. So what voltage should we use? It depends on the size of like the power of the equipment. It depends, like there is a lot of considerations, and to this regard, like there are different levels of powertrain voltages. The most common is like what we call below 60 volt, typically 48 volt nominal. Then there is some machines that actually run on 96 volt and thereabout. So that's a mid voltage. Then there is levels at a 400 level and 600 and 800 levels. So different things, and all of these voltages have different consideration. So that's one aspect. That's the traction voltage. That's the main voltage of the machine. But there is another consideration which actually has to do with the auxiliary functions within the machines. Typically, in a lot of systems, those have been historically 12 volt. But some machines actually use 24 volts, especially for the machines where the actual, like the auxiliary function are very, very far from the power source. So 12 volts usually doesn't work, and 24 volt is used instead. But now more and more the industry is looking at using 48 volt as an auxiliary voltage rather than 12 volts. So there is a movement in the industry toward that direction, but it will take a bit of time. But I think ultimately, probably in the next 10 years, 48 volt would become the standard for auxiliary functions on the machines. But today, it's mostly 12 volt, and some applications are 20 volt. But the OEM, as they are looking at the future, they should have this consideration for these different voltages. Then after that's defined, then we start actually looking at the energy, like sizing, what's like the size of the battery, of the um, motors, the converters, the wiring on the system, the cabling, etc., etc. So like that's the third step, having to do with energy and power sizing. And then the last consideration, actually, which actually relate quite a bit to off-road vehicles, is power takeoff. And some applications, like for example agriculture, that's a very important aspect, because there is functions that need to be powered by the vehicle, but that are outside the vehicle. And that's what the importance of actually determining what are the need for power takeoff from the machine. Once these aspects are considered, the last one that the OEM will go to is actually choosing now the components, choosing the motor, the motor, choosing the converters, choosing the actual components. And the recommendation here primarily is to stay with commercial off-the-shelf product whenever it's available, because it will take too long. It's too expensive to actually do custom design for different machines. So our recommendation is to use as much as possible off-the-shelf solutions. Now, many of the industries, for example, let's say construction equipment or agriculture, are new to this field, and there may not be a lot of components available for that, like dedicated to this specific industry. And that's where actually OEMs need to look at other industries that are more advanced in electrification. So, for example, material handling equipment, for example, is very electrification in material handling equipment. I'm talking here forklifts and pallet jacks and etc. is very advanced in terms of electrification, which is reaching like levels of 80% of the equipment globally that is electric. So they have developed a lot of solutions today, and there is a lot of components that are available in this industry. Another source actually of the equipment could be is the automotive sector. Automotive sector, which is way advanced in electrification and much more mature. However, the challenge with that is that microcosm for actually serving the automotive industry is geared toward very high volume. Which is not like the business model is not very suited for small production runs that are typical in off-road vehicles, as well as the environment conditions for the components. So the components have to be chosen such as they are rugged and then suitable for off-road applications, which has a lot more environmental stress and constraint on the equipment. And then the last aspect, but not the least, is choosing actually the right suppliers. This is a very important consideration because the supplier when an OEM is embarking in a new way of doing things is of very high importance. So that's suppliers are not like commodity suppliers, but they are actually partners. They are they supplement the skills of the OEM to achieve the goal, and then speed up the development and have reliable solutions. So I'll return the mic to Andreas.
Thank
For
you.
consideration.
Thanks, Murat. I appreciate it. I think it's been quite obvious that there are a lot of things that need to be considered going into electric drivetrains. Coming from the last slide, we are starting basically with components. So here we are looking at the battery system first off. What are the basic questions that need to be addressed when one starts basically from the scratch, having all the variables on the table. I think most and not simple, but most largely one is that one needs to define the form factor. So one looks at the existing vehicle, if it's possible to use the engine room, or it has to be adjusted there to fix the battery packs in. Also, center of gravity are things, most of these vehicles also need counterweight, and then the advantage here can be seen that the battery system can be part of that, integrated into the vehicle, let's say, gravity structure. Then there is the question of how are things fixed together, making sure it can basically resist and stay in place for the time of operation. The system the machines are outdoor used, it's heavy duty, also in extreme temperatures. So there will be exposure of pressure washing sometimes, or of course rain, mud, and all dust that comes along to the components. So the ingress protection is very important to take care of. There's nothing going in between screws or causing sparks or any safety related problems. or even, of course, the very simple one, the machine is shut down, then the downtime starts counting, which is actually the advantage of the electric drivetrain, that the uptime is higher because there's lower maintenance. So ingress protection, a core element of that. Then, as Murat explained already, the profile, the machine profile, the user profile from the target user in the market. So what kind of machine is it? Where is it used? How many hours it's been operated? Comes then down into the duty cycle that basically relates into the power requirements. That's peak powers that also will then have peak voltages going through the system. So coming from the architecture, what is one selecting there? Is it low voltage or medium high voltage systems? So that all plays into the duty cycle definition. And once that is defined, then one can decide how much capacity the battery bank actually will have. So to make sure the entire system operates smoothly, difference, I'm not saying it too hard, but the internal combustion engine is an analog machine, I would say. Of course, there's a lot of electronics around that, coming from the controls and making whatever sensors and actuators around it. More an electric system or intelligent system, but still in the core, it is an analog device, and you need to add sensors to get things measured. In a battery system, you have still the chemistry as being let's say the analog part of it, but since the entire system is controlled and managed by the battery management system, it is already a digital, I would say, device that can then start communicating with all the other components in let's say in the same language, a communication language. So the bus system is a key design requirement. You need to make sure all the components speak the same language. Otherwise, you'll be making adjustments and modifying on all sides. That costs time and money. I think we can go to the next slide. Once we looked at the basics of the battery system, and we know what kind of performance we need to get out of the pack, it's by far not done, because then actually the hard, tough job starts. Most of the systems are being operated quite long time, and as I said, in a heavy duty environment. So shock and vibration is something that is consistently engaging into the battery pack. Therefore, one needs to make sure everything sits in smoothly. The components itself are rated to operate in such environment. And then it's not only the component, they play together then into the whole system that needs then to be certified again to meet the standard there. The next part then is coming into the compatibility to all the other components in the system. So again, here is the communications is key. One needs to make sure the wheel control unit or the chargers are being in the same, let's say, in the same communication space. And ideal here, coming back to what Murat already mentioned, supplier selection is key. So if you already have a battery supplier that is working together shoulder on shoulder with a charger manufacturer, then these integration jobs can be done very quick, because protocols are synchronized, and therefore one has a more efficient, also a cleaner system in terms of whenever the edge cases come along. That's the problems I think that come up in the field. You can define duty cycles, but then machines act in certain environments, in climate conditions that you cannot test in every chamber, and then you need to make sure where it's coming from. Was it from a charger? Was it from the battery? And there, that basically compatibility is crucial. Battery systems need to be scalable. So once one has a platform of products, one starts with a smaller battery pack, but then should be able to actually grow in capacity. Otherwise, you have to redesign the battery pack again to make it bigger or having more capacity. There is a modular approach is certainly a preferred version. that gives you the flexibility that, for example, if machines are operated in cold climates where normally more energy is required, that means more battery capacity, more modules in the system. The OE can offer different, let's say, machine types for different climate zones or let's say regions. So therefore, modularity is a good and a key aspect to have a good integration on the battery design. And then, of course, we've all learned it through the Corona crisis, COVID, where all our supply chain managers were basically in daily operations finding new suppliers or alternative components because the supply chain was not stable. So also on the battery side, safety of supply is crucial, because once one is going into larger, let's say, production, and we've seen it already, because then once the product is well designed, the adoption can be very fast. So the safety of supply is crucial. So can the supplier basically cope with the demand? Has the forecast been discussed properly? Is the capacity there in the factories, the global scale there? So can it be supplied through other regions as well? So that's part that goes into the design operation. Last but not least, here is the country scope. So batteries are dangerous goods. So you need to take care on transportation. You need to take care during handling. If something goes wrong, then you need to file an RMA and bring them back and analyze them, take them off the site. And that is not an easy job. And if the battery system has no proper certification, that's actually can be a showstopper. So there's logistic companies that will not touch a battery system that has a problem. And therefore, it's important to take care of that as well. Then the next slide is basically talking about the pitfalls, so lessons learned. We have first off to look at the machine, and customers come and say, well, I'd like to have a specific battery pack that needs to operate that and that long, it needs to be in that form factor, and up in a sudden it turns out to be a custom design. But the custom design is again prone to errors if there was no proper design specification phase in the beginning. So making sure every detail has been defined properly. So when one goes into, let's say, a proto stage and then towards pilot builds and mass production, that the agency is being done, and then nothing can be changed. Otherwise, you have to redo it again. So very important to have the appropriate customer data to design something custom. What we've seen also is the lack of experience in the integration, which cause a lot of trouble. People, as Murat already said, come from a different world in internal combustion engines. There's no such electric systems that the design teams have been working on, and then the teams need to work outside of the competence fields, or let's say outside of the comfort zone, and then of course experience can be lacking, and that plays out into faults on the design, and then can create some issues. After sales support is crucial. So nobody's perfect, we know that. And again, coming back to battery packs being dangerous goods, if you have an after sale that is engaged and you have tech support teams that take care of and find the mistake and help you out immediately, most of the things can be done with a good discussion, finding out how has it been installed, where are connections being done wrong, was it during charging, during discharging, and then things can be sorted out. But if the supplier doesn't have a proper after sales support globally, then it can be tricky. So that's something one needs to consider. And last but not least, and I'm repeating that, but it's a really important subject, is the logistics. Battery logistics being dangerous goods is a task for itself. There is companies out there basically doing all that, but it's good to have the knowledge also on the battery supplier side. Then going forward, when in the field and one decides to expand into other markets globally, into new territories, one can find out that these markets have their own regulatory requirements, and if the system design wasn't taking that into consideration, that means even though it has been homologated in one country, it cannot be used in another country. That will be basically an abrupt limiting factor. So market entrance is not possible. Therefore, it needs to be taken care of. Also, that the supplier know what to do. So it's a guidance that needs to come there. It needs to be teamwork from both sides, understanding where the system is going to be operated. Yeah, and then other parts is then the protection coming from the intelligence of the BMS. So the battery management system has functionalities that help on the operation side, making sure the performance is there. Also on the failure diagnostic is part that needs to be handled. By far most important, of course, is all the safety that is being carried out by the BMS system, protecting from short circuits, thermal runaways. What we've seen in the field is really important to have the right system there. Never save money on the BMS. That's one thing I can say, right? Yeah, and then in the end of the day, also the pitfall, once you're running in production, then you try to sell more, but then there is no supply. So whatever the cell has been phased out, it's the end of life, the supplier hasn't taken it into consideration, up in a certain product is no more available. So these are things that, we can say from a battery perspective. And here I think Murat takes over again, looking at the chargers.
Continuing with the design consideration, actually related now to the charger. So we have to look at the battery size, of course, like as we said earlier, type and size, the nominal voltages, as we said. Now, it is important to consider how long will it take to charge a battery, and then that depends on the usage, but as well as the battery capacity to absorb the charge. And in here, like consideration about the charger relate to, is it like on board or off board? Are we using standard charging? Are we using fast charging? So different considerations that actually have to be taken with regards. And in this, it's important actually to consider the charger when you are talking about the battery, and consider both these aspects earlier on in the design cycle. Unfortunately, a lot of OEMs leave the charging and the chargers as the last things, and that in many circumstances actually delay the project. So the charger, like one of the things we are seeing here is actually the charger is not just to charge batteries, but more and more OEMs and vehicles need more functions that actually are put in the charger, such as, for example, having DC-DC converters to supply the lower voltage equipment, such as, or it could be actually an inverter to supply to provide export power from the vehicle, etc. And the last consideration in here is, where is the electricity coming from? Is looking at the plugs, looking at the infrastructure available, looking at the voltages. Are we using charging stations, which is actually becoming more and more in the off-road industry, coming from the on-road charging infrastructure, but same thing is being used for off-road vehicles. The equipment being used is off-road, so that means there is a lot more constraint on all the equipment. It's a very rugged and like there is a lot of shocks. There is a lot of swing in terms of temperatures. It's used in extreme condition, dust. Very cold environment, very hot environment. There are liquids. There is contaminant. There is all kinds of things. So the charger needs to be very rugged and reliable. And this, like the machines typically are expected to live for a long time. So the batteries and the charger, the components need to be very rugged. One important consideration actually that is new. Would be new to OEMs is EMC, electromagnetic interference and immunity. So those are a very important aspects that are nuances. Now everything is electric, so there could be potential interference between the different components as well as interference to the grid. So these are aspects that need to be considered early on in the design process and being tested earlier on. And finally, the regulatory compliance of the machine and of these different chargers, especially with the heightened level of safety that is required for having potentially dangerous voltages on the machine. So what some of the problems that we learned from our experience actually supporting different OEMs is the availability of the power. So in a few instances, there wasn't enough power available on site, or the plugs and the infrastructure, the electrical infrastructure available was not enough to support these machines that typically have a higher level of power requirements. So there will be some adjustments there, and the OEM as well as the end user need to be prepared for that. One of the pitfalls is actually we have seen is some OEMs, they choose a non-standard powertrain voltage. For example, and that's for convenience because of the battery size or because of this consideration. For example, they pick a voltage of, let's say, 150 volts. It's not a standard voltage. So it will be difficult to find components to work with that, and we advise against that. I would advise to stick as much as possible to standard voltages because there will be availability of components to support that. And as I mentioned before, is picking up the charger late in the development process, very late. So I think the charger have to be one consideration earlier on as you are choosing the different powertrain components. Continuing with additional problems is a very important aspect, and Andreas has mentioned that, and then I repeat it again, is the supplier ability and customer support capabilities, either technical or logistical, or also knowledge of the environment, of the regulations, of the standards of how to do things. The supplier is not anymore just a commodity supplier. It's an expert. It supplements the OEM capabilities and technical skills. Thermal management is an important consideration whenever, like especially with the chargers, because typically they are dense components and need a proper thermal management to work properly. And doing the EMI AMC testing late in the integration. What we recommend is to do it early on and keep doing it. Like this is related to not only the charger but also to the wirings, to all the electrical system that is on the machine. And with that, we will conclude with like this is the key takeaways that we can take from this presentation. When OEMs are considering electrification of non-road mobile machinery, they have to look at the voltages, the nominal voltages, either traction or auxiliary. They have to look at the site infrastructure. We advise to use as much component of the shelf components available rather than going for custom designed, to look at the charger and the battery together as a system and ensure compatibility, and also consider them earlier in the design process. Choose the right supplier, and that's actually a very important consideration, that like suppliers that have the skills but also that can work together. Quality management is important for all OEMs. System integration and design to compliance, because there is more regulatory and more standards that need to apply to these machines, as well as doing iterative testing. Like, don't leave it to the end to do the final testing. Do as you go, do the testing. So that's to save time towards the end. And that concludes our presentation. So I'd like to thank you and open the floor for question and answers.
Thank you so much, Murad and Andreas. We do have a few questions here from the audience. I'm going to read out for you now. So the first one is, what does the battery voltage trend look like? Would 800 volt be the standard or any other higher voltage? Is the trend similar in China?
Yes. So the trend voltage is there are some trends, especially for bigger machines, toward the higher voltage. The higher voltage, the better performance and of the machines, and the faster the charging happen. However, it comes with implications in terms of safety, in terms of complex systems, in terms of availability of the components. So what we have seen is a lot of some of the machine. It's better to like from an integration development. It's better to stay with the lowest voltage that you can, right? Because of it gives more flexibility. But the trends are pushing like. But if you can't, then you go higher in the voltage. Currently, a lot of machines are 48 volt. Many are at 400 volts and 700 volts. 800 volts is coming. There is still a little bit lack of components to make it possible in off-road machinery.
Perfect, thank you. The other question is, what checks should be done with communication of a battery BMS and charging system? What information should suppliers be asked for?
Yeah, maybe I can answer that one. I think we already touched it a little bit in during the slides. It's about the synchronization and like say the supplier quality to be able to design a system to a certain level that makes the job first of very not easy but easier, because then you can assume that there's protocols in place that can be adopted. So we say there is a non let's say integration level, a semi integration level, and a full integration level, where non integration means the charger is actually not speaking to the BMS. On the semi integration, the charger is basically has a synchronized profile that basically knows the end of charge voltages, but doesn't really speak yet to the battery system in a bidirectional way. And then the full integration is when you actually have a smart charging. That means the BMS system sends out commands to the charger that gives then the appropriate, let's say, algo for charging to make sure the battery is charged quick, sustainable, and not overcharged, or doesn't run into problems during the charging phase. So there are parameters. I think protocols are important. So J1939, the CAN bus is something to mention that needs to be existent. Ideally following standards there in that sector. More than that, I think is then in between, again, the handshake. And ideally you have a battery manufacturer, BMS manufacturer that worked already with a supplier from the charging side, and then things are quite simple in the integration because protocols are already there and you can just plug them together and they will work.
Okay, I think we have time for one more quick question. Does region impact charger performance and or efficiency?
Regions.
Regeneration.
Region.
Yeah. Mm-hmm.
Regeneration. Regeneration. It doesn't affect the charger efficiency, but it does affect the runtime and the ability actually to size the batteries. So if regeneration is available, then you could downsize the battery, and you have more runtime. And of course, yes, it comes with and net result of that is higher efficiency because there is less outside energy that's needed to operate the machine.
Perfect. Well, thank you so much, Murad and Andreas. We've received too many questions. We won't be able to cover them all right now, but we'll be collecting them in a document. We'll be sharing in the same place in the lobby where you can find this on-demand video. So I would like to thank everyone for attending this session. And please join the next session from the lobby to make the most out of the future of electrification. Have a wonderful rest of your day, everyone, and goodbye.
Thank you. Bye-bye.
Thank you. Bye-bye, everyone.